In this video, we are going to look at radians and arc length. So we're going to start off with radians. The first thing you need to know about radians is it's another way to measure an angle instead of degrees. The actual definition of a radian is how many times the radius can be wrapped around the circle. So first thing we're going to look at is converting between the two forms. So to go from degree to radians, radians normally has a pi in the answer. So we are going to multiply whatever the degree is by pi over 180. And so the way I remember that is because there's a pi in the answer, pi has to be on top. To switch directions, to go from radians back to degrees, you're going to multiply, we are multiplying by 180 over pi. So we're going to take that original fraction and flip it. And again, the way you can remember this, 180 is the number of degrees, so if we're trying to get degrees, the 180 has to be on top. So we're going to go ahead and do like two examples for you guys, one of each. So the first one, 135, I'm trying to convert it to degrees, so I'm going to multiply this by 180 over pi. And what you can do from here is just multiply straight across. If you want, you can make that 135 into a fraction and then multiply straight across the top. Oops. Sorry about that, guys. I don't know how I changed the screen. Ooh, there we go. Okay, let's try this again. So we get 135 pi all over 180. So next you're just going to simplify the 135 and the 180. So right away I know I can divide them both by 5. So dividing them by 5, I end up with 27 pi over 36. And then I can divide that one step further. I can divide them both by 9. And that can't be simplified any further, so that is going to be my final answer. So 135 degrees converts to 3 pi over 4 radians. So let's take a look at our next one. So the next one we have 7 pi over 2, so that is a radian. So I want to convert that to degrees. So for this case, I'm trying to get degrees, so I put the 180 on the top over pi, and I multiply straight across the top, straight across the bottom. So I have 7 times 180 all over 2 pi. And then I can cancel out the pi on the top and the bottom. And then I can just go ahead and simplify the 1260 and 2, which equals 630 degrees. So notice we can have angles larger than 360. That is not a problem. So 7 pi over 2 is 630 degrees. So the next thing we are talking about is arc length. So it's exactly what it sounds like. It is the length of an arc on a circle. To calculate it, we have a pretty simple formula. So to find the arc length, you are going to multiply the radius times the angle. And the one catch is the angle has to be in radians. That part's really important. So if you're given an angle in degrees, you will have to convert it. So the way we write that formula, we would say the arc length is equal to r times theta. And because it's multiplication, the order doesn't matter. So if you want to put theta first, that is perfectly fine. So if I take a look at number 3, I have a radius of 14 feet. I have 5 pi over 6 as theta, as my angle. It is in radians already, so all I have to do is multiply those two together. So I have 14 times 5 pi over 6. And from here we are multiplying straight across top and bottom. So we can make 14 into a fraction, and then we multiply. We end up with 70 pi over 6. So if your directions said to leave your answer in terms of pi, that would be this. Because our directions tell us to leave it to the nearest, round it to the nearest tenth, that means we want to actually plug in the number for pi. So we're going to do 70 times 3.14, or you can use the pi button on the calculator, and then divide that by 6. So when we do that, we end up with 36.7, oops, not degrees, feet. So that would be the length of the bolded arc right here. So moving on to number 4, first thing I notice, I have 315 degrees, so I'm going to have to convert that to radians. So if you remember to convert to radians, we have 315. I'm trying to get pi in my answer. So I have pi over 180. And then we're going to go ahead and multiply that across and simplify. Oops. And once our answer is fully simplified, we get 7 pi over 4. So that is my angle, so I'm going to multiply 8 times the 7 pi over 4. So I get 56 pi over 4. You can simplify that one more time if you want, or you can just go ahead and multiply it out. So that is what I'm going to do. So once we simplify that, we get, this one rounds up to 44 feet. So that is how you would find the arc length. Now, our last problem is a little bit different. So this time they tell us the angle is 60 degrees. It has an arc length of 5 feet, and we are trying to find the radius. So in this case, we're going to set up our formula, but we have the arc length. So we have, let me write this out a little nicer. So my formula was the arc length equals the radius times theta. So my arc length is 5. My radius is what I'm trying to find. And then my 60 degrees, I do have to convert that to radians because right now I have it in degrees. So I'll do some work off to the side here. So 60 times pi over 180. Once you reduce that, we end up with pi over 3. So this is my little equation that I have to solve. 5 equals r times pi over 3. So I have to get rid of the pi over 3. Right now it is being multiplied. So what we're going to do is, we can't divide fractions, so instead we're going to multiply by the reciprocal. So I flip the fraction and multiply that on both sides. So if I bring my work over here, I get 15 pi, oops, I get 15 over pi for the radius. Normally your question would say leave it in terms of pi or round it to this something decimal. So since this one doesn't say, I am going to leave this one in terms of pi. So my radius is 15 over pi. So if you are given the arc length and asked to find a different element of the equation, you're going to plug it into the formula and then just rearrange the equation like you normally do.